Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 8. Let's consider this network consisting of 5 resistors labeled R1 through R5 as well as voltage sources Vs and current source Is. The question is to calculate the power supplied by the voltage source. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 4 meshes. Mesh number 1, mesh number 2, mesh number 3, and mesh number 4. Now let's proceed to assign the mesh current in this network, and I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, and I4 is the current in mesh 4. The mesh currents are chosen in the clockwise direction. After we finish the assignment of the mesh currents, we need to remove the branch containing the current source Is. Then we obtain our supermesh. By applying KVL in the supermesh, we can write R2 I2 minus I1 plus Vs plus R3 I3 plus R4 I3 minus I4 is equal to 0. By replacing the resistors and the voltage with their numerical values, we obtain 4I2 minus I1 plus 10 plus 2I3 plus 2I3 minus I4 is equal to 0. If we continue simplifying this equation, we obtain negative 4I1 plus 4I2 plus 4I3 minus 2I4 plus 10 is equal to 0. And I will call this equation 1. By applying KVL in mesh 1, we can write R1 I1 plus R2 I1 minus I2 is equal to 0. That means 10I1 plus 4I1 minus I2 is equal to 0. If we continue simplifying this equation, we obtain 14I1 minus 4I2 is equal to 0. Finally, I1 is equal to 4 over 14I2 is equal to 0.286 I2, and I will call this equation 2. Let's move on now to mesh 2. By applying KVL in mesh 2, we can write R5 I4 plus R4 I4 minus I3 is equal to 0. By replacing the resistors with their numerical values, we obtain 2I4 plus 2I4 minus I3 is equal to 0. If we continue simplifying this equation, we obtain 4I4 minus 2I3 is equal to 0. Finally, I4 is equal to 0.5 I3, and I will call this equation 3. We currently have 3 equations with 4 unknowns, which means we require an additional equation to solve this problem. In order to get this equation, let's focus on the current source Is. We can write Is is equal to I3 minus I2. That means I3 minus I2 is equal to 2 amps. Finally, we can write I3 is equal to 2 plus I2, and I will call this equation 4. After we finish applying the supermesh analysis, we obtain 4 equations with 4 unknowns. We still only need to solve those equations to obtain the mesh current I2. Let's start first by substituting equation 4 in equation 3. We obtain I4 is equal to 0.5 multiplying by 2 plus I2 is that means I4 is equal to 1 plus 0.5 I2, and I will call this equation A. Let's move on now by substituting equation 4, 2 and A in equation 1. we derive one equation in terms of I2. If I continue simplifying this equation, we obtain negative 1.144 I2 plus 4 I2 plus 8 plus 4 I2 minus 2 minus I2 plus 10 is equal to 0. We obtain finally 5.856 I2 plus 16 is equal to 0. That means I2 is equal to negative 16 over 5.856 is equal to negative 273 amps. The power supplied by the voltage source Vs is equal to Vs multiplying by the current I2. That means the power is equal to 10 multiplying by negative 2.73. We get finally negative 27.3 watt. After we finish calculation, we have done simulation using SPICE simulator in order to verify our simulation. Let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is the resistor R1, R2, the voltage source Vs, current source Is, the resistor R3, R4 and R5. If we go to analysis, DC analysis, calculate nodal voltage, we can see here that the power supplied by the voltage source is equal to negative 27.32 watt, is exactly the same value we have done by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. Have a nice day and bye bye.